we discuss here how to find the coordinate of center of gravity of a circular arc. Right? Now we first see that what is circular arc. Okay. Here this is a circle. Okay. Now we take only a part of the arc. Let it be the part of the circular arc. Right? This is the part of the circular arc. Let it be A. We have to find the center of gravity of this circular arc. Now this is the center of the circle. Let it be at O. And we join OA and OB first. Let two lines OA and OB makes angle 2 alpha at the center. This is 2 alpha. Okay, that is angle AOB. This is equal to 2 alpha. And we draw a line in such a way that it bisect the angle 2 alpha. That means this angle is alpha and this angle is also alpha. Let it be x-axis. Right? And the perpendicular through O to the OX is taken as y-axis. Right? Now we have to find the center of gravity of the circular arc. This is A. Now what is the definition of center of gravity? We know that if we write the coordinate of CG is G, this is equal to x bar y bar, then x bar, this is equal to integration x dm by integration dm. Right? This is the total mass of the body and this is the elementary mass and this is the distance of the any particle. And we see here for this particular type of curve, this curve is symmetric about x-axis, right? Because there are same type of portion on two sides of x-axis. So this is symmetric about x-axis, and for the symmetric body about any axis, the center of gravity must lie on this axis. Okay, because two sides have same mass. So here if the center of gravity lies on x-axis, so its coordinate must be transferred to G is x bar comma 0. Now we have to find only x bar. So this is our only formula to find x bar. Here we take an elementary arc. Let it be ds. Okay, and we know that if this is the point P and it makes angle theta with x-axis, then we know that ds, this is equal to a d theta, because for the circle is equal to a theta, where a be the radius of the circle. Now for dm we get rho into ds, where rho be the density of the material of the string. Right? So this is dm, and this gives rho into a d theta. Now for this point P, the coordinate of this point is xy. So in polar form we write x, this is equal to a cos theta, and y, this is equal to a sin theta. Okay, so we put here integration, this is a cos theta into dm means rho a d theta, and integration rho a d theta. Now what are the range of the integration? Since we taking first, this makes angle 2 alpha, Okay, upper side of x-axis is alpha and lower side of x-axis is alpha also. So the range of the integration is minus alpha to plus alpha, because this is the clockwise direction and this is the anti-clockwise direction. So the range of the integration is minus alpha to alpha, and here also minus alpha to alpha. And now by integrating we get a rho a square into, this is sine theta, and the range are minus alpha to alpha, and this is rho a into theta, the range are minus alpha to alpha. So rho cancel out, a cancel out, so we get a into sine alpha minus sine of minus alpha by, this is alpha minus minus alpha. So this is a into sine alpha, this is 2 sine alpha by 2 alpha, so we get a sine alpha by alpha. Hence we write the coordinate of CG of the circular arc is given by G, this is equal to x bar comma 0, and this is given by a sine alpha by alpha comma 0. If we take this circular arc as semicircular arc, okay, then our range of integration is minus pi by 2 to pi by 2. So from the result we directly get the coordinate of semicircular arc by putting alpha, this is equal to pi by 2. And in this case, for semicircular arc, CG is given by G, this is a into sine pi by 2 by pi by 2 comma 0, and G into sine pi by 2 means 1, so we get 2a by pi comma 0. Okay, this is the CG of semicircular arc, and this is the general formula if the angle of semicircle making at the center of the semicircle is given by 2 alpha. Right? So, and this is very easy and simple process to find the CG. Thank you for watching.